Assalamualaikum and good day everyone. My name is Muhammad Rusdi Bosman, metric number TCY044, and my partner is Muhammad Shamsul Hassan bin Hashim, metric number TCY030. Now I would like to present our title, which is Heat Exchanger. Generally, heat exchanger is a device that allows thermal energy to be transferred from one fluid to another fluid without mixing the two fluids. To prevent mixing, two fluids are usually separated by a solid wall that has high thermal conductivity. Convection in each fluid and thermal conduction through the wall separating the two fluids are the most common method of heat transfer in a heat exchanger. Heat exchanger may be found in a variety of places, frequently operating to heat or to cool buildings or to improve the efficiency of motors and machinery. A heat exchanger is most commonly found in an internal combustion engine, where an engine coolant flow through the radiator coils and air flow past the coils, cooling the coolant and heating the incoming air. The heat exchanger are used in a variety of applications in power engineering, including steam generators, fan coolers, and cooling water heat exchangers and condenser. Other than that, refrigerators and air conditioners, for example, employ heat exchanger in the opposite manners, that central heating system which they extract heat from a compartment or room that is not needed and pump it away in a fluid to another location where it may be discharged out of the way. The cooling fluid is totally enclosed inside a network of pipes, so it never comes into direct touch with the air where it extracts heat energy from the air within and dump it in the air outside, but it never mix with that air. Next part, I will pass to my partner Samsul.
The components of the shell and tube sheet exchanger is tube. Next is a tube sheet. Then we have a shell and shell side nozzle. We also have a tube side channel and nozzle, baffles, and last one is a tie rods. The fundamental points of the shell and the tube heat exchanger is to pass a hot fluid through a cold fluid without mixing them, so that's only their heat is transferred. The shell and tube heat exchanger has one fluid flowing through the metal tubes and the other fluid flowing around the tubes. On either side of the tube, heat is transferred by convection. Then the heat is transferred through the tube wall by the conduction. The working of the shell and tube heat exchanger is very simple. One fluid flows inside the tubes and the other through the shell. While flowing, they are exchange the heat, which means the cold fluid gains the heat from the hot fluid. The one cold fluid enter the shell inlet nozzle and come out of the outlet nozzle as the whole hot fluid. Obviously, the other fluid will become cold in the outlet than in the inlet. The heat transfer in the shell and the tube heat exchanger is determined by the exposed surface area that is decided by the number of the thermal conductive metal tubes. The fluid flow inside the shell and tube heat exchanger can be parallel flow or cross flow. Performance of the heat exchanger is the first one is online and offline cleaning. The online cleaning will help to prevent the foiling and scaling without having to shut down the heat exchanger. Next one is the maintaining heat exchanger. The best way to boost the heat exchanger efficiency and increase output is to implement a good maintaining practice that avoid the fouling. The last one is the minimizing the fouling factor. Heat exchanger efficiency is highly affected by the velocity of the operating fluid, so it is recommended that the flow rate should be increased from time to time. That's all from us. Thank you.